Hello everyone, January 16th. Alright, I'm gonna do one for today and later I'll do another one for tomorrow. But first things first, the contest yesterday. Uh, didn't do very well. I finished three, as usual, in about half an hour. And because of some oversight, I'm gonna take a look at my ranking. Because of some oversight, I had some mistakes. I had quite a few mistakes, especially especially the third one, right? Let's see, I have two mistakes on the third one, and it took way too long for the first one. I wasn't in my best shape. So the first one took way too long. Second one, I think, is also a mistake, and third one was vastly mistaken. Like the third one is a very basic dynamic programming, but I just got carried away. Like, oh, I know how to do it, but then I don't do very well in that situation. So overall, it was bad. Oh, I thought it was 43 because I have three mistakes. Each mistake add 5 minutes. So it's 15. Yeah, it's 43. That was bad. It was bad. And I just finished the last question. Look at this guy. This, I think he's like rank number third, number two globally. He did the number four first. All right, it's a he did number three first. He did three, four, two, and one. The amount of confidence. All right, so the difficult one, it was quite tough yesterday. I didn't know how to approach it, and I had to read a hint this morning. And I was driving this morning, and I kind of think it over, and I got the idea, and it passed. But the good solution is even better. The good solution is even better. All right. Anyway, so we're just gonna do this and not anything else, as we hit 4 yesterday, 3 yesterday, 1 today. If this one is something we've done, then so be it. The maximum distance to closest person. Ooh. Maximum distance to closest person. Never done this before? I don't think so. I don't remember this drawing. I just said I don't remember this drawing. Now, I kept saying they reuse the same questions, but actually, I think almost most of the time when they reuse the same questions, the test case changes. So I think that's still considered a good thing. And never voted, never do anything. You're given an array representing a row of seats, okay? Where seat I equals 1 represents some person sitting on the ith seat, and seat 0 representing that the ith seat is empty. Perfect. There is at least one empty seat, and at least one person sitting, at least 1, 0, and 1, 1. Alex wants to sit in the seat such that the distance between him and the closest person to him is maximized. It's like finding a stall to pee. That's what you want. Find the one that has maximum distance to other people. Return the maximum distance to the closest person. So this one will be, why is it 2? Sits in the second open seat, and the closest person has distance to 1, 2. I see. So just so like if I pick 5, that will be 1. Distance 1. So it's just index, the difference between the index. Okay? So that will be here, so it will be 3. That will be 1. Okay. I mean, if we grab, but you can only sit in between, right? In between people. All right. A special case. We grab the index of all the seats that has been taken, right? And we iterate through all the seats, and for all the seats out, we can sit, and we can do So basically, I say if I want to sit at a certain position, right, then we need to find out the index of the people sitting here and here. So basically, it's a binary search in this method. It's just we have a sorted list of this, and then we start from 0, right? And then, right now we start from 0. We can actually also list all the empty seats, right? And then every time we loop through the empty seats, we get one. Binary search, find the distance. Binary search, find the distance. But why do we do that? It has to be in the middle, right? To maximize the distance. So we just get these, and then we find this, we find the next one. The difference between this divided by 2, right? 0, 4 divided by 2. And then we swap. Isn't that the case? And we're going to start with the -1, right? Because 0, 1, right? And a 1, that would be 0. Maybe that is the solution. Hold on. That will be a lot easier than I had expected. I was going for the binary search, but I realized maybe we don't need binary search. Because if you want to sit, the best option is always in between. So all we need to do is find the indices, right? Just find the indices. So what it say is we have a left person, left will be -1, right? And then I'm going to say for s in seats, is, enumerate it, fs, right? Which means if somebody sitting, then we have result equal to 0, right? Then res shall equal to max res I minus left and divide by 2, right? And once we're done, left equals s, and we return res. Let's put the rest of this together. Okay. All right, let's run some test cases. Okay, first one is this 2. Second one is this. Be 3. If there's a potential issue, I can already see a potential issue. We'll never hit a 1 here. So I should return. Yeah. So I think the second one will be wrong. Let me just double check this. The second one is wrong. Right, seats. Second one should be wrong. Yep. Because I need to do this. Return max. Res and so this one will be 0, 1, 2, 3, right? So the next person should be here, right? What I can do is I just do seats dot. Yeah, or just dot pen 1. And then I think return this. Ooh, that is not right. If C star, well, hold on, why would this one be false? So it'll be 0, 0, 1, 2, 3, 4. 4 minus 0. divided by 2, it shall be 2. What's sitting here? Wait, why does the result is 1? It's interesting. I minus left divided by 2. So I want to sit here, all right? If I want to sit here, oh, shoot. If it's the end, it's no, that's not true. That's not true. That's not true. We can't, this scheme is useful if it's enclosed. And we put a -1 here, which means that is also not true. That is also not true, because if we do 0, 0, 0, 1, which shall also be 3, and I think this scheme is going to fail as well. Yeah, this scheme also fail. It shall be 3, because here 1, 2, 3. Therefore, the starting position, because we know, right? The starting position, it depends. If the first is 0, for the left, right? So left should be -1 if seats 0, else if seats not 0, then else shall be, what is the else? Oh, that's interesting. Else, if the start was not a 0, then the strategy is always to sit here, right? Strategy is always to sit here. How do we handle this? This is actually easier to handle. How do I handle this? Where's my starting point? I have an idea. If S, right, and we say if left is equal to -1, so that's the first time we hit, right? The first time we hit, and seats 0 is equal to 0. So it's the first time we hit, then res equals to, that will be the first value that we hit. So that shall be I. Yeah, that shall be I, right? Else, how about this? First time we hit, and the left is 0, then we do. Otherwise, first time we hit, if first one we hit, and the left is not a 0, then we just do this regular, which is completely fine. Or the first time was not the first time we hit, and the left is 0, which is also fine. Okay, so this I can solve test 3. Yes. So now we just need to solve the last one. The last one can be solved here, which is just the last one, right? So we're going to return res, the maximum of res and something, right? So we say if seats, the last one is 0, right? If the last one is 0, then we shall return whatever the 0, 1, 2, 3 minus 0. So it shall be I, because when it comes out, I is n -1 minus left, right? So we're going to do this. if this, else 0. That's not right. Hold up. So left shall be 0. What's I? I is 3. What's left? Oh, it's not dot. My bad. Left is 1. How? How is left 1? Oh, shoot. That's I. My bad. How does it even pass all the others? Like, seriously, how do you even pass the others? Said it left the wrong number. Yeah, I want rest equal to I, but this is rest minus left divided by 2. So in here, that'll be 0 minus this. Number 0, right? I just want some left value to begin with. Again, left value we can begin with 0, it's fine. We can begin with 0, that's fine. But it's more like a sentinel, right? We have a sentinel here. That's the first one. And then, okay. Let's try this. I'm pretty sure the solution might be simpler than this. Okay. I want to try something else. I feel like there should be an easier way. Not like conceptually, but just implementation-wise. What if we grab all the indices out? Okay? We grab all the indices, and then we can do a zip. Right? That's all we need, a zip. So let's do this. Let's do indices equals for I as in enumerate seats and I if S, right? That's the indices. Then we do zip indices 1 and indices and indices 1, right? Indices 1, right? And then we're gonna say for this is left, right in this, and then right minus left. Right, I'm gonna say rest equals maximum of this, and then return maximum of rest, indices 0, and indices 0, which correspond to the first one 0, or indices last one, which shall be -1, but we need to do a len seats. Len seats 0, 1, 2, 3, 3 minus -1 minus this. Okay. How about this? It's empty sequence. But which one is empty sequence? This is the empty sequence. Oh. yeah, indices if it's 1. Ah, if len indices. Hold on. If len indices is larger than 1, then we can say rest is 0. Okay, we failed the first one. Oh, divide by 2, my bad. Forgot to divide by 2. Okay. Can we further simplify this? This is the kind of the front back, and this is if it's larger than 1. I think that's about it. I think that's the easiest we can do. And then if we want to make it shorter, we can just, instead of calling it indices, IDs. How about IDs, right? And then we want to call, let's just call R. Let's call L. Yep. So basically, find the indices of all seats that are taken. The best place to sit is always between each consecutive pair of indices. Find all the seats are taken. The best place to sit is always between each consecutive pair of such taken seats. The tricky part is to consider the situation where there are empty seats starting or ending the row. That's ON. Yeah. I think it's easier than this. Let's try it. 128, exactly. Same as last time. 89%. All right, let's just take a look at how we did it last time, and then we're gonna call it. We are going to call it. That was the last time. How come I can do it here, but I cannot do it now? It's the same. Oh, I tried to do a max here, which I should not. Ah, plus. Yep, this is better. But hey, it's fine. I know the idea, but this is better. We'll do the max at the end. I don't know why I do max here. It doesn't make any sense. Yeah. You know what? I don't like this, right? We don't like this. So we're gonna say potentials will equal to, I'll call it pot. We like to call it pot. Right? This is the pot. And return max pot plus. Yeah, it's the same as this. Exactly the same as this. Yep. Alrighty, that's for today. I will see you guys later today for tomorrow's challenge. Adios.